our next speaker will be Peter Thomassen. That unfortunately was affected by a bit flip of the time zone. And now we'll talk us about bit flipping of root servers.
Thank you. Yeah, so I'm sitting in this cafe, just ordered breakfast, preparing my lightning talk slides, and then Benno calls. I'm like, what a pleasant surprise. And then turns out I had my Indico set on the Berlin time zone, and I thought we start at 10:30, and yeah. Sorry. Anyway, so bitflipping root-servers.net. Yeah. So bitflips, very briefly, is essentially when in memory a bit changes for you know, unintentional reasons, from overheating, cosmic rays, and other stuff. It affects integrity, of course, and if you want to exploit that, like for example, if somebody sends a packet to an IP address but actually sends it to another IP address because bitflip, then you don't need to reverse engineer, you just need to listen on that other IP address, then you get the data. And yeah, so mitigations are, of course, error correction, and you could, with respect to domains, of course, do defensive registrations. Yeah, so that's essentially what's there to say about bitflips on a very high level. There was an experiment by Warren. Is he here? I don't know. There. Last year, he presented at an ICANN meeting that he registered microsont.com, which is a bitflip of Microsoft.com. And then there is interesting traffic that arrives for API endpoints and other things. And so there's a link here if you want to check it out. And I thought, like, what happens with bitflip variants of root-servers.net when name servers try to do priming queries? So here's priming queries. It's essentially when a name server tries to get the IP addresses for their you know, root host names that they have in their hints file. And the bold sentence here is root server identifier and addresses change. Sorry, root server identifier and address changes are the main reasons that resolvers need to use priming. So I thought, I'm not a resolver operator, but they apparently requery that because it might have changed. What happens if there might be a bit flip in memory before that requerying happens? Also, we already have that pretty much. Here's an example of how a priming query looks. It's a it's a query for the NS record type for the root zone, and it returns, of course, the NS records, and then there's also glue attached to that, which I should have pasted, I suppose. And there is the hard-coded stuff that the name server resolver starts from, which is the hints file. It has sort of the same zone file format shown at the bottom here, and it has the IP addresses that the name servers start with, and they might replace that by making a query to the root and see what happens. So this is all intro. And if you take that stuff over because you somehow manage to spoof a priming response, then at least for those GTLDs that, or TLDs that don't use DNS-OARC, then you might be able to control the traffic. All right, so here's the root servers experiment. We registered a bunch of domain names which are bitflip variants of root-servers.net, and then on those, in those zones, when there is a bitflip, then the resolver might actually query for A or B or something .bootservers.net or suitservers.net or whatever the bitflip is, and we needed to see that traffic and respond to that traffic if we wanted, to sort of set up a fake root servers infrastructure. So that name server system that runs that, you know, that responds to A.the bitflip stuff, B.the bitflip stuff, that is the root-servers.net infrastructure. We registered 48 bitflip variants of root-servers.net. I think there is 56 total, but 8 were already taken. But they are not, I think, malicious, right? There is like boot servers, anyone, I don't know, maybe somebody sets up a boot server and then registers that name, so it didn't seem malicious. One of the variants became available during our experiment, so we registered it after the fact. And so an interesting thing is there is an asymmetry in whether you clear or set a bit, because if you look at the ASCII table, you can go from, I think, a digit to a letter by changing the bit the one way, but not the other way. And so that causes that asymmetry. And yeah, so the data was collected in Europe, essentially, at Hetzner, but my university allowed me to store it, so thanks to them, Rutgers University, New Jersey. And yeah, so we stood up these zones there and collected 220 gigabytes of data between July and January 2026. And this was the first iteration of the experiment. There is another iteration after that, which I'll get to. Initially, we only looked at the address record queries for the single letter .bitflip versions of the root server domain. So the setup is, as I explained, those are the two name servers that are authoritative for all the root server.net bitflip variants. And on these two VMs, we collected the traffic. This is from the first of these two VMs, and this is daily traffic for the single letter bitflip variant names. For A and quad A queries, you can see there is a few thousand every day, and there is some spikes because Pedro told us DNS and internet is noisy, but I couldn't find any correlation with Cosmic Rays or anything like that. And the same thing is visible here on the other VM. Looking at the query sources, this is client IP addresses. There is also a few thousand v4 and v6 sources every day. So not very special, just to show you there is some traffic, and of course there's always some traffic for something. But remember, those are queries that are not some random queries arriving at the name server infrastructure. Those are queries that match the single letter dot and then the bitflip variant of rootservers.net pattern. Here is a difficult to read rainbow pie chart about which bitflip variants are most frequent. Essentially at the top you can see the larger red slice, which is rcot-servers.net. And so that is the winner. And there is also root servers.net, which is the second winner. And then all the other ones essentially had the same average number of queries in this observation window, which were like 34,000 queries roughly. The winner had over 100,000, which is why the slice is 3 times as large. And the minimum was 2,200, which is weird. I don't know why any name would be particularly uncommon. There was one name that had 2 bitflips. It is rcot-servers.net. 3 times that happened, which is, I guess, quite unlikely to happen if it's really random. And if you look at the table on the right, you can see which are the bits that flip for O and K, and for E and U. So for the 2 winners, it's the 3rd bit and the 5th bit from the right. And so actually, that is a pattern that we will see again on the following slides. I forgot for the one with the double bit flip, rcot-servers. Does anyone know whether V and R is also the 3rd bit? I think it is, but I'm not sure. Whatever. Yeah, I think it is. It's a difference of 4, right? So that's 2 to the 2nd. Okay. So that's the double bit flip in the 3rd bit, which looks like a hardware issue, I think. So the same thing here for quad A queries. Nothing new except that the overall number is lower. And yeah. Those are prefix frequencies that were seen. So those are single octet 3rd labels, pretty much. So that's on the 2 name servers. On the left-hand side, the 2 tables are the usual single letter stuff. And that's essentially the same as the pie diagrams I showed you. On the right-hand side are other things that are not A to M. I was quite surprised that there is such a diversity of numbers of queries. So the wildcard is quite common. Then there's also the backtick. I'm not sure why that is. And then there's a bunch of other like seemingly random stuff. I didn't attempt to make more sense of this. All right, so the second step was that we serve a real root zone on the servers which run on the addresses that we return for a single letter the bitflip version of rootservers.net. We did that for a few months, and we collected 146 million queries in the data set, 75% of which were any queries, and 24.6% of that were TXT queries for domain names that have very large TXT RSS, like cisco.com. If you want to figure out, check it out right now, it's like a 10 kilobyte TXT RSS or something. So that seems to be an interesting one for amplification purposes, just like any. So it seems like almost everything that arrived at these name servers that we set up was sort of amplification, well, suitable. I don't know whether it was really the reason. So we pruned that, and about 0.1% of the traffic was left, which was like 60,000 queries, and we didn't know if that's a lot or a little. So we thought maybe we need to refine the experiments because we didn't really see whether we could actually hijack any sort of traffic. we just served the real root zone. It was a DNS-dist proxy that forwarded to the RIPE root server, I think. And we just recorded the traffic. So a few interesting instances here are from a European mobile ISP. This is in July and September and October, so it's a recurring thing. The subnet here is always the same, I think. I mean, the XXXYYY part of the IP address. And things tend to relate to cars for some reason. So there is the Garmin geolocation thing, Volvo cars, and then something Amazon vehicle subdomain. So it seems like there is maybe car systems that use European mobile ISP SIM card. And for some reason, they might be doing the resolution on the device, which has the SIM card, and then that device has faulty memory. I don't know. Yeah, so from EU West to EU CEST, or from dash to closing parenthesis, I think it's also 4 away in the ASCII table, so it's all the 3rd bit. Then at the bottom, from the same subnet, but we don't know, or I didn't reconstruct what domain name that was related to, there was the ck.uk lookup for Amazon name servers, which was supposed to be a co.uk lookup. I'm counting the alphabet. I think that's also the 3rd bit. So I think all of this is the 3rd bit that is switching. And those are not the only queries, by the way. I picked those because they are from different months, but the pattern is actually more consistent throughout the time. So then we improved the setup. Originally, we only responded to the single letter .bitflip version of the root server's domain names only, and we didn't serve any SOA, DNS key, whatever, because it was, in fact, only a DNS-dist deployment that had like a Lua response hook. We then replaced this by a real zone on a real name server that behaves normally for NS and SOA and DNS key queries, because we thought maybe some resolvers get thrown off by that domain not behaving normally. So we did that. And also we added a real root server name when asked for a bitflip name on a different IP address. So for example, if you ask for the address of a.root servers, whatever, something bitflip.net, we would respond with the query name, so that's the first line in the response, and some IP address, which is some VM, where we serve the real root zone and record traffic. And we would also respond with the non-bitflip version, even though you didn't ask for that, because depending on where the bitflip happened, whether it happened in the infrastructure, like in transit, or after you ask the question, or before you ask the question, it might be that we actually get the bitflip query, but the client is expecting the non-bitflip version. And we wanted to know whether that happens, so we returned 2 different IP addresses for that, and in the PCAPs we can then see when any resolution change gets hijacked, which IP address they get delivered to, and then we know which of these records was followed. Same thing for IPv6. All right, so we then also thought, well, originally there was the priming idea, so maybe we should not serve the entirely real root zone. Maybe we should serve the real root zone except for the NS record set at the apex, which is the prime inquiry response. And so we replaced that with 2 other host names and again separate IP addresses, so that we could see whether any resolvers would, in our logs, first go through the single letter lookup, then later do an NS query for the root, and then end up sending queries to those addresses they get from that step. So that would indicate there would be like some sort of resolution hijacking. And for any referrals, we actually did serve the real root, so we didn't hijack anything in practice. All right, so this was only in February for 2 weeks, and then different things happened, like the experiment stopped, and it'll continue in June, but the data here is not very much, but it's still interesting. So what we found here is that there is again cars involved, but this time it's in the US, the Ford Transportation Mobility Cloud, and the IP addresses at the top are the ones you get when you query through the single letter.bitflip thing, and a priming query was done, and then after that there were A queries to the 2 IP addresses delivered here for the fake priming response for the autonomic.ai thing, which is some transportation car platform. And so then that resolver apparently latched onto this infrastructure. Another one is this one here. why am I showing this? Which is that IP address? Yeah, this is an example that shows another random bit flip from .com to AOM. What I'm really trying to show you here is that the .com domain, CC-sec whatever, is a CNAME to something CloudFront. And we did see a lot of follow-up queries trying to resolve this CloudFront thing. So apparently, some resolver latched onto our infrastructure, still got the right CNAME without the AOM bit flip from some other name server, then went back to our name server and tried to resolve CloudFront. So I don't know exactly how that worked. That's infrastructure from the Volvo and gbook thing. Gbook is a Japanese, no longer operational navigation system, I think. gbook.jp. Or gbook.com. So they also ended up using the IP address from our fake priming response. There's also Volto cars, which is again a bit flip of Volvo cars. I think there's only 2 away. So same thing like AOM and .com. So that's the second bit apparently repeatedly at Volvo devices. I don't know why. And so then there was some other related lookups for volvocars.com. I showed you this here, Volto cars. The name server of that, or one of them, is udns2.cscdns.uk, and that again has a name server which is under .org, and that requires looking up GTLD name servers, and that's why we have queries for that in the dataset too. We didn't defensively register any of the GTLD servers bit flips, but that would be an idea too that one could do. But it's sort of expensive, right? Yeah. Anyway, and that's pretty much it. So the summary is that we observed around 10 million queries for the single letter bitflip names and around 100,000 queries on the fake root servers after pruning, but without serving the fake root zone yet, just observing the traffic. And then when we added the root server serving, so the root zone serving, and replaced the priming response, we got roughly 10 hijackable resolution cascades in those 2 weeks. So that is interesting. It seems like it's worth expanding, and VeriSign was kind enough to actually provide us some resources to get more storage to do that over the next year, so we'll start in June. And the plan is to add some more parameters like which countries things are coming from, which AES, what's happening in DNS-OARC aspects, and so on and so forth. And then look at this again. Yeah, it's not a big security issue now because we've taken the names. And if we hadn't, I don't know if it would be a security issue. I guess I can probably give an update on that next year. So, thank you. Here's the VeriSign logo.
Thanks a lot, Peter. Question from the audience?
Come up here.
Yeah, but now it's on, yeah. Giovanni Modus Identity of Delft. Nice, very nice work, but you talk about a lot about bitflip, but you cannot tell what the root cause is, right? It can be fat fingers of people mistyping stuff, right?
Yes, but so I wouldn't expect that anyone in a Volvo car types in the name at query time. So if it were a hard-coded error, we would see much more of that. So I think it's a hardware fault in that case, at least. But of course, it's possible that people make typos. You can look at the keyboard, and at least, depends on the layout. But the way that we picked, so you notice, for example, that A and B.rootservice.net and O and M.rootservice.net, one of them is for the bitflip variance zones authoritative. The other one is the infrastructure saving the fake root zone. And they are not close on the keyboard, so you couldn't fat finger that, for example. So we tried to take some of that into account, but of course you never know, and you don't know what fraction.
Yeah. And do you plan to submit this work as a paper for a conference or something? And if you do, how do you deal with ethics about this? Because that would be certain.
Yeah, so my view is ethics are independent of where it's published, so I think we should think about this anyway. I think this is ethically fine because we didn't do any PII stuff and we didn't manipulate any actual traffic. Some ccTLD, I don't know if that's public, so I will not say who, allowed us to hijack their domain. And actually, they were like, if somebody sends you a query and you send a referral elsewhere, why don't you just do that? We don't care. And it turned out that we actually didn't receive any queries for that ccTLD. That would be ethically more interesting, but I think what we did is completely fine. And about the publication, if someone wants to write a paper, I'll be happy to provide the data.
Okay, thank you.
Hi, it's David Gross from Nominet. In a past life, a provider in Brazil operated a name server on a bitflip of the IPv4 address of the K route and decommissioned it and saw a tiny, tiny trickle of traffic turning up there just because the IP had been bitflipped. Mm-hmm. And I just wanted to add that that's another case of bitflips in the wild. It was a tiny trickle. It was like a few requests a day, but...
So this was a bitflip of the IP address?
Of the IP address, yeah.
Oh, cool. Yeah, I'd be interested in whatever, like if there is an article about this or something, or...
That this is just stuff from like 10-year memory in my brain. I don't think there's anything more than that, other than somebody was like, why is this happening? And I was like, I don't know, this is weird. And then I was like, wait, that IP is familiar, but not quite. Oh, wait.
Yeah, cool.
Greg Chewels, ISC. Research is nice and a little scary in places. Is there a takeaway from this, as in, we should do things to mitigate this happening? Or is this just an interesting...
That's a very good question. So there is a few things that come to mind. Defensive registrations, but that's sort of conceptually it's a what's the word? Workaround. Mm. Then there is, of course, hardware mitigations. You can use error correcting memory, and that might be important if you run a resolver, but that's also more expensive. I don't think that any Volvo cars, or I'm not blaming Volvo actually, but any chips in cars would use ECC. And then there is DNS-OARC, which might be an interesting aspect when you actually manage to hijack something. And but I actually think the risk is quite remote, and the numbers are, at least seem to be quite low. It'll be interesting to see within the next year whether any more popular resolver, like some instance by some ISP, for example, latches on for a few weeks, and then all the customers go there. That would be, I guess, a reason to start thinking about what to do about it. But given the numbers now, I haven't thought too much about it. But if you have suggestions or anyone else...
Okay, so remote question. Petter Mensik from Red Hat says, do you think it's even a good idea to have cars resolve names by iterating from root hints? Which is a bit of a silly question, but you can give a yes or no.
What was the second part? A good idea to what?
To have cars resolve names by iterating from root hints.
I'm not a car manufacturer.
So my question off the back of that is, did you actually give them a heads up since you saw a lot of stuff coming from their infrastructure?
No, we didn't. It seemed like the systems were all pretty old. Some of them were not even accessible anymore. We just saw the queries. And I don't think it's a good idea to do resolution on the car. But yeah.
I think that the takeaway is that DNS works by just the sheer force of its will. Or perhaps it's pure magic and the magicians in this room keep it afloat. I mean, thank you. Interesting and mind-blowing at the same time.
Okay, cool, thank you. I guess then that's it.
Yeah, thanks, Peter.
Thank you.